Good afternoon, everyone. My name is Sineva Elizaveta. I'm a postgraduate student at Bauman Moscow State Technical University. And today I'm going to talk about the use of artificial intelligence methods to assess the fracture toughness of materials in space environment. But my presentation will focus primarily on the technology of the expert systems, but I hope that these findings will also resonate in specialists on material science. So the relevance of the study is associated with the fact that elements of space technology are exposed to high temperatures, and it leads to the formation of microtracks and erosive layer and threatens structural integrity. And when the spacecraft is being designed, it's possible to use expert systems that contain information about the characteristics of each part of the spacecraft, including information about the materials and geometry. Such systems can help engineers spacecraft design and give some recommendations on the materials used in the spacecraft design. And such systems should be reliable, and the interaction of the between the expert system and the designer in the natural language should be effective. That is why the purpose of this work is the reliability of such systems, and to improve the reliability for accurate assessment and prediction of fracture toughness of materials in space environment. And this presentation will be divided into four parts, four aspects of expert systems reliability. So just briefly about the expert systems, that's just the artificial intelligence system that includes knowledge about the specific domain that can partially replace an expert specialist in solving a problematic situation. So particularly, we're talking about the knowledge and material science and different properties and characteristics of materials. In the foundation, in the core of the expert system is the knowledge base. And the problem is that because of the continuous increase in the amount of unstructured knowledge and material science, it leads to the problem of reliability of such intelligent systems. And the first aspect, how to solve this problem, we should find the appropriate knowledge representation models. So there are different models like semantic networks with concepts and relationship between them, the logic of predicates, condition, action rules, that just the sentences, if, condition, then action, in the frames. But I would take this knowledge representation model separately. They can't fully describe the particular subject area. They can't give the full descriptions of materials and their properties. That is why we propose an integrated knowledge representation model that combines all the structures, that's the pref structure, frames, predicates, and predicative symbols. And this structure should guarantee the consistency of descriptions of the objects and their relationship in real production. And this abstract hierarchical structure is presented on the slide. So the next aspect for information and system reliability of the knowledge base, here we define three processes of its operation. The target process means that all the tasks of the system's life cycle are solved. The certification process, it means that all the tasks that stands for conflicts resolution, and sensory process means that all the tasks that expert system solves are accompanied by the relevant information from the knowledge base, and it leads to the controllability, observability, and survivability of the system in general. The next aspect is that engineer maintains just the interaction between the human and the expert system. make some queries in the expert system, and the problem is in the information or knowledge retrieval from the expert system, because such queries in the natural language, they can include polysemantic words that can have more than one or two meanings, and we solve this problem embedding the thesaurus in an information research model. That's just the online, that looks like an online dictionary, like the structure of the network with the concepts and relations between them. And it provides the number of synonyms for each term and for each concept. For example, it expands search for fracture toughness to include crack resistance, key parameter, and so on. And embedding thesaurus into the probabilistic information research model included 3 stages of the analysis: to perform a search by adding synonyms, to calculate metrics like precision recall, F measure for the results, and comparing the indicators with the basic model without using WordNet, and comparison of information search efficiency by these metrics for a simple query like fracture toughness and complex query like the temperature below zero. Comparing the results, it gives the higher measure precision and recall, much more efficient when the knowledge-based search is performed with the use of WordNet, with the WordNet embedding compared with the knowledge-based search without embedding the dictionary WordNet. Here you can see the comparative results of information search efficiency. So the green columns with the use of WordNet, embedded WordNet. We can see that WordNet adds semantic links to expand and deepen the search in the knowledge base of the expert system to provide efficient interaction between a human engineer and in the natural language. In the last aspect of the reliability of such systems, that's the optimization of terms in the knowledge base. Any object in the expert system is called, in the knowledge base, is called a term. Could be words, numbers, and sometimes it's important to check the terms in the knowledge base for different mistakes. The mistakes in spelling, the mistakes in numbers, points, and so on. And we can combine all these features of terms in one generalized indicator using the desirability function to evaluate the effectiveness of expert system in the form of the specific number, to delete and correct the incorrect terms. So just moving on to the results of my research, the core challenge is that fixed crop materials face extreme temperatures that leads to microcracks and degrade fracture toughness. And AI system components like the use of expert systems provides the knowledge base, and it solves a specific problem, the information, for instance, expert assets, semantic networks that links concepts, and thesaurus like WordNet that improves search recall in scientific databases and technical documentation. And in conclusion, I will also highlight that we focus on developing and investigating such expert systems, and one of the possible applications is material science, and we believe that specialists in material science can find these results interesting and applicable in their sphere. So thank you so much for your attention.